So great, this will be our last lecture on kinematics. After this we will start with motion in plane, right? So let's continue with our remaining set of problems from NEET PYQ. Our next question is, what will be the ratio of distance moved by a freely falling body from the rest in 4th and the 5th second of its journey, right? So time is given how much? 4th second and 5th second, correct? Now we know when something is falling down, right? Okay, and we are looking for nth second. So nth second distance formula is Sn equals to u plus a by 2n minus 1. Here acceleration will be acceleration due to gravity, right? So what we will do here, we will find for S4 u initial, because it's a freely falling, as per the question, freely falling, so initial velocity will be 0 plus so I'm not writing here this g, I'm just keeping it g, later on we will make it, okay, because things is we have to find the ratio, right? So no need of putting it here. It will be 2 into n is how much? 4. 2 into 4 minus 1, right? So this will give us S4 will be equals to g by 2 into 7. 2 4s are 8, 8 minus 1, 7, correct? Equation 1. Now let's figure out for our 5th second. So 5th second, using the same relation, S5 will be equals to, u is again 0, a is g by 2, 2 times n, so 2 times 5 minus 1, correct? So this will be g by 2 into 10 minus 1, 9, correct? I hope this is clear. So now you got 9g by 2 and here you got 7g by 2. Let's divide both. So equation 1 and equation 2, when you divide 4th and 2nd, S4 upon S5, that will be equals to 7g by 2 whole divided by 9g by 2, correct? Let's cancel out this g by 2 with g by 2, you're left with 7 by 9. So our correct answer is 7 by 9, option B. I hope this is clear. Okay, let's move to our next question. Question next says, a car moving along a straight road with a uniform acceleration, it passes through 2 points, point P and Q. So let me just write here this as P and let me assume this as point Q, separated by a distance, okay, with the velocity. So at point P, the velocity is 30 km per hour and at point Q, the velocity is 40 km per hour, correct? Respectively, the velocity of the car midway between point P and Q. And there is a direct relation for this particular thing, and that relation is velocity will be v equals to root under v1 square plus v2 square whole divided by 2, right? This is direct, but we will derive it, okay, because these are revision lectures. I will derive this so that you will recall how we got this particular expression, right? So let me start with this. I am removing this and we will see at the end the same relation we get, okay? Okay, so let's assume that the midpoint here is any point r. So if this is midpoint, this distance is x and this distance will also be x, right? And let us assume that at this point this velocity is v, which we are looking for right now. Clear? So what we will do here is, we will for PR we will make use of our distance from the equation of motion, v square minus u square is 30 square equals to 2ax. Acceleration is fixed because the question is saying it is uniform acceleration. Uniform acceleration means a is fixed, x is this distance, correct? So a will be here v square minus 30 square whole divided by 2x. I hope this is clear. This is equation 1 we got from PR, correct? Now let's do it for RQ. So for RQ, what we will do for RQ? The same equation. Here the velocity, final velocity is 40. So 40 square minus v square, and that will be equals to 2ax once again, correct? Clear it is? So you can take this 2x on the other side, or you can keep directly 2ax, you can put it this one, okay? So let's substitute, or you can take it that way if you want. So since it's a uniform acceleration, a will be again here 40 square minus v square upon 2x. Equation number 2. Let's equate equation 1 and equation 2 because both are same, constant acceleration. So this will give us v square minus 30 square will be equals to, upon 2x is equals to 40 square minus v square whole divided by 2x whole divided by 2x. You can cancel out 2x both the sides and you're left with your equation v square minus 30 square will be equals to 40 square minus v square, correct? Let's take this v square that side, so it will be 2v square will be equals to 40 square plus 30 square, and v square will be equals to under root, sorry, not v square, it will be v will be equals to under root 40 square plus 30 square whole divided by 2. Now if you recall, at the beginning of this problem, I gave you the same expression at the beginning, right? From here we get v1 v2 square upon 2. So v 40 square, that will give you how much? It will be root under 1600, and that will be 900 whole divided by 2. Now 16 plus 9, 2500. 2500 root is 50. 50 by root 2, correct? Let me repeat again. 1600 plus 900. 2500. 2500 root is 50, correct? Now that is root 2. Now if you want to rationalize, it will give you root 2 upon root 2, and that will give you how much? 25 root 2, which is option C is correct. I hope this is clear. Let's move to our next particular problem. So our next problem is this one. Okay, so we got first graph problem from PYQ. The displacement time graph of two moving particles makes angle 30 degree and 45 degree with the x-axis, the ratio of their velocities, right? Now we know if we are given with a displacement time graph, I'm just recalling the concept here, displacement time graph. If you are given, in case if you don't know, the slope will give you velocity. The slope of displacement time graph will give you what? Velocity. And there are different ways to calculate this slope. In case if you are given with angle, straight away the slope is nothing but tan of angle theta. So tan theta will straight away give you velocity in this case. Sir, what if the graph is not of displacement and time? Then in that case you will get different things, right? If in case of displacement time, if it is velocity time, the slope will give you tan theta will give you acceleration in that case, okay? Or any other different things you will get different, okay? In subsequent chapters you will see that. So here displacement time graph is given, so slope is tan theta, and that is our velocity. So velocity of the first one will be v1, that will be equals to tan theta 1, and v2 will be equals to tan theta 2. If you divide both, you will get v1 upon v2, that will be equals to tan theta 1, which is tan 30 degree upon tan 45 degree, correct? And by 10 standard, I hope you know tan 30 is 1 by root 3 and tan 45 is 1. So correct answer is 1 is to root 3, that is option A. Clear? So this we got from graph straight away. Let's move to our next problem. Great, we have another graph, another curve. The question says a particle shows distance time curve as shown in the figure. Fine. The maximum instantaneous velocity. Now if you look at the graph is increasing like this, right? It is increasing like this. So maximum instantaneous speed or instantaneous velocity from this particular graph will be at point C. At C it is increasing, then again it is getting stable. So C is the point. Option B is the correct answer, okay? It's slowly increasing, it is getting maximum nearly C, at point C, between C and D, and then D it is again getting nearly constant. So C is the point where it is maximum. Let's see the next problem. Great. The displacement time graph of moving particle is shown below. The instantaneous velocity of the particle is negative at which point? So if you can see, the graph is increasing like this, okay? If the graph is increasing like this, what is happening? At C it is positive, at D it is positive. Now D to E it is getting negative. At purely E it is negative because the slope is negative. It is going down, right? Again it is increasing, again it is positive. Be very careful between displacement time graph it is. So E point is the point where it is negative. So option D is correct answer. Clear it is? Let's see the next one. Okay, which of the following curves do not represent motion in one dimension? So let's understand all of these one by one and see that which one is not matching. Option A, you can see that the velocity is increasing, okay, becoming maximum, then decreasing. Possible it is, right? We can see that velocity increases, then decreases, right? Let's see the graphs. This C1. Here again, initial velocity was there something. So if the graph is not starting from 0, it simply means the particle has some initial velocity. So if initial velocity is there, the graph will increase like this, correct? In B, what you can see is if I make a perpendicular here, making a perpendicular, what I will get? I will see that there are two values of V corresponding to the same time. Now, what does this mean? It simply means for a given time, there are two velocities, two different velocities, which is not possible for a particular journey, right? For the same time, two different velocity for the same particle, not possible. Here, the velocity increases, decreases, becomes negative, again increases, positive, and so on. So possible. Only option B is not possible. So this is our correct answer in this case, that B graph is not possible because they are asking does not represent motion in one dimension. Clear it is? Let's see this one next. The next question is over here. A bus is moving with a speed of 10 meter per second on a straight road. A scooterist wishes to overtake the bus in 100 seconds. If the bus is at a distance of 1 kilometer from the scooterist, with what speed should the scooterist chase the bus? Clear? Let me explain you the scenario. One day, you are going to your college or your school, and this is your bus. You are taking bus every day. Clear? Okay. What happened that day? You forgot the lunch, and one of your, let's say your dad, okay, on the scooter, he found that you are in the bus, and the bus and your dad has a separation between them as of 1 kilometer, right? So this is your dad, this is your bus, okay. The gap between your dad and the bus is 1 kilometer. Bus is already traveling with a speed of 10 kilometer per hour, right? 10 meter per second, sorry. Clear? This is the data given, okay. And your dad wished to overtake this bus in 100 seconds because he has to go to the office. So to give you lunch, he has only 100 seconds. With what speed should he move so that he can overtake the bus? Concept is clear. Very simple scenario. So what is happening here is this relative separation. Relative separation is how much? 1 kilometer, which is 1000 meters, right? Relative separation between the bus and the scooterist is 1000 meter. Okay, great. What is the speed of the bus? Speed of the bus is 10 meter per second. Speed of scooterist, sir, we don't know. We are looking for that. If both are moving in the same direction, if both of them are moving in the same direction, they are chasing each other, right? And in that case, what will be the relative velocity? V relative will be equals to, now, often, sir, I get confused. It should be VB minus VS or VS minus VB. Now, let's take a very simple realistic example. If I want to go and overtake this bus, my velocity should be greater than the velocity of bus or should be less than the velocity of the bus? Sir, obviously you have to overtake, so you should be higher. So velocity of scooterist minus velocity of bus. Be very careful with this, right? This is the real. Sir, why minus? Both are pointing in the same direction, right? If two objects are moving in the same direction, their relative velocity is VA minus VB, correct? Okay, so this is relative velocity between the scooterist and the bus. This is the relative separation. So time will be equals to distance upon speed, or speed equal to distance upon time. We can do that, right? So what is the time? Time is 100 seconds given here. Distance, sir, 1000. Relative speed is velocity of scooterist minus velocity of bus, which is 10. Let's cross multiply. So Vs will minus 10 will be equals to 1000 upon 100, 10. Let's take that 10 on the other side. Velocity will be equals to 20 meter per second. So the scooterist must be moving with minimum 20 meter per second just to overtake the bus. I hope this is clear. Let's see the next one. Great. Quite similar problem on relative velocity once again. A train of 150 meter long, okay, is going towards north direction. So let's say this is our train and the length of this train is 150 meter, correct? So this is our separation, okay. It is moving towards north direction like this, okay, at a speed of 10 meter per second. So let me write here the speed is 10 meter per second. A parrot flies at a speed of 5 meter per second towards south. So this is a parrot moving with 5 meter per second towards the south. Clear? In direction parallel to the railway track. The time taken by the parrot to cross the train. Time taken by the parrot to cross the train. Basically, it has to travel 150 meter, right? But the train is moving towards it. So what will be the relative separation? The relative separation will be D, that will be 150 meter, right? Both has to cover. Then only they will cross each other. 150 meter they have to cross. And this is moving with 5 meter per second down and this is moving with 10 meter per second up. So relative velocity will be velocity of train plus velocity of parrot. Opposite in direction, so that will be added up, right? So what is the velocity of train? 10 meter per second. Velocity of parrot? 5 meter per second. So relative velocity will be 15 meter per second. If the relative velocity is 15 meter per second, relative distance is 150 meter, then time will be equals to distance upon speed. Distance is 150, speed is 15, so correct answer is 10 seconds. How much time the parrot will take to pass the train? 10 seconds straight away. I hope this is clear. Let's see the next one. So this will be our last question. This question was asked last year, okay, in your NEET. So let's see what it is. I hope the graph is not that clear, but I'll explain you, don't worry. The velocity time plot of the motion of a body shown in the figure, right? So this is our velocity, this is our v, and this is our t, and the graph starts like this and this. Okay, conversion graph it is basically. The acceleration time graph that best suits the motion will be which one, right? Okay, so velocity increases, then velocity becomes constant, then velocity decreases. Without looking at the options, let's understand, analyze this graph, right? So velocity increases, clear, uniformly. So acceleration will be constant and it will be positive. Why positive? Because it increases, right? And uniformly increases. It's not a slopey curve, it's a straight curve. So straight curve, it will be constant acceleration. Here, when the velocity is not changing with time, you can see the velocity is not changing with time in this interval. Here, when you differentiate, the velocity is constant, acceleration will be 0. Here A is 0, here A is positive, and here when the slope is going down, A is negative. Clear it is? These are the three scenarios: acceleration positive and constant. Be very careful. Acceleration 0 because the velocity is constant, and acceleration negative. So which scenario suits the best? Not the first one, not the second one, not the fourth one. Acceleration constant, 0 acceleration in this interval, acceleration negative and constant. Clear it is? So the correct answer for this one was option 3. So here we have completed all the problems NEET PYQ from kinematics. Next lecture we will start with our motion in plane. Clear? So in case if you have not watched the previous lectures, link is in the description. You can watch it, and if there is any suggestion, you are always welcome.